connecting with that horse race example, that what we are doing is we are looking at the problems of that horse race example and slowly introducing distributed programming. And this is the fundamental for Hadoop. Whatever you are going to build on the top of this is what is going to be covered in all the subsequent sections. Even if you go to Amazon, Azure, Google Cloud, everywhere, what will be counting is this particular fundamentals, okay, how the file system is. Okay, so,
HDFS.
right. So, let's look at the problems one by one. Traditionally, the computation has been processor bound. What does that mean? Whenever you write something, a code you are writing in your particular program, let's say add two numbers, right? I want to write a function, integer, add, in bracket, integer a, comma, integer b. Don't worry about programming language, you'll understand what I'm doing. So I'm going to write return a plus b. This is how normally in all languages a function will look like, right? For adding two numbers, correct? Assume that when I execute this particular function, what will happen? Where is it getting executed? It is executed by using the CPU, the processor of your laptop, correct? And now, assume that I want to repeat this operation, like the horse race example. I want to repeat this operation for, let us say, 1 trillion numbers. That's exactly where the problem starts. Big data is all about big data. Trillions, billions of data, correct? One of the table that I am dealing with today has got about 900 columns and 517 million rows. Just imagine that you want to write a standard JDBC program to just read it and print it, right? You are gone, right? Come, right? Your friend is not here. Yeah.
I think Vara and Ravi, they both.
Oh, they are not
they
here.
both went out.
Okay. So, 900 columns, 517 rows, and if I am writing a particular program to read that particular data, it's gone. I can't do that, right? So, big data is all about larger data. But traditionally, we believed in doing the computation on a processor. And what the people started doing is that, okay, let's don't assume 1 trillion, let's assume, let's say, 1 billion. When that 1 billion rows came in, they told that, okay, take your computer, add RAM. That's what exactly we did in the last class. I told you, for virtual machine to work very well, and for all your big data applications, you need to increase your RAM.
That's what I did.
That's what everybody is doing, right? Oracle is slow in your company. They'll add RAM, first thing. And then they will add cores. Don't worry about that now. The moment you are adding cores and the moment you are adding RAM, Oracle will knock your door. What they will tell?
More money.
Yeah, absolutely. So they'll tell that we sold the license for 4 cores, but now you make it as 16 cores, the license increases. So imagine in the big data world, all the Twitter feeds, all the Facebook data, all the database data, you want to process, how much RAM and how much thing you are going to add. So what happened is, a great scientist is there, Moore's law. What Moore's law states is that every year the processing power doubles and the size halves. Processing power is doubling and the size is half.
And the cost is.
Cost also, correct.
Right.
But Moore's law specifically talk about processor and size, that's all. What happened? All the years they started, processor is increasing, size is decreasing, processor is increasing, size is decreasing. And read this article, okay? You will just note it down in your book or something. Wikipedia, Intel, Tejas failed and presenter. So you will see a beautiful article, okay, in Wikipedia. I want you to just look at it, take a look when you get into home. Tejas and Jayhawk. That's the heading of that particular article. And go through the first paragraph, and then you will see a line. This is what I want you to concentrate. Cancellation to heat and power consumption problems. They could not reach higher clock speeds. Look at that. Oh, okay.
Yeah, I thought I wrote it.
2018 at the rate. This is capital. All right. So what happened is you should connect to PassionBytes 5. What happened is they could not go further. That's the reason after 486, 586, Pentium, is there a 686K? Is there a 786K? No. Stopped. You couldn't. They could not do that. And they failed. And when they failed, they started thinking different way. Oh, okay. One CPU called Pentium or 486, which is marked like this, is creating the problem. Let's do one thing. Take the CPU, this is your CPU, and create something inside. And make sure that each of this is powerful as a CPU. And what is this called? What is that called? Cores.
Dual core, what?
That's where the dual core, quadra core, all these things came in. Now you got multi-threading, the facilities and all, right? So that's where the technology has gone from the traditional computing to this. Okay. Now,
So can I ask one?
Yeah.
Each core, right, that people call, I'm not much familiar about multi-threading. So what it means exactly, how that works?
if I write a 12 horses running, the 12 horses will be managed by one single CPU. But here, the 12 horses, you will divide it into 3 horses, 3 horses, 3 horses, 3 horses, so that now you got a better management. Is it good that one manager is managing 12 people, or you've got 4 managers with 3 people under them?
They're threads, each horse.
That's what. Okay? So, and now the people started doing something more. What is that? Okay, this is one computer. Now let's create another computer with again another. And now join these two. And pass messages. Message passing interface. PVM, Condor, all these are the technologies. And the first one who implemented this very efficiently is the first MPP database, world famous, is Teradata.
Oh, I work with that too.
So MPP is used internally, right, by Teradata. And Oracle came up with Hexadata at a later point of time.
Exadata. Oh, that's what we just migrated to.
Absolutely. So Oracle
DBAS.
comes up with it. That's also an MPP database.
Yeah.
Right? So BOA uses.
Yeah, we just migrated to this.
Yeah,
this
don't
music.
disclose confidential reporter.
Huh?
Right. All right. Okay. And now, programming traditional distributed systems is complex. What happened when you did like this? I told you all the problems, right? Coordination. Assume the horse race example. Some horses here, some horses here. What will happen if it is failing? Clearly understand that points. What happens if these are two different operating systems? What happens if one is failed and coming back at a later point of time? What happens if these are having different RAM? This is CPU. Here it is 4 GB RAM. Here it is 2 GB RAM. What will happen? You don't know. In a competition, when you are doing the horse race example, everybody should be getting the same environment, right? You cannot give some horses running in very powerful and some horses running in very slow computer. Then how can you tell that it's a competition, right? If I am conducting an exam for you, I should give the same question paper to all of you. I cannot give easy to him and difficult to him, right? That's exactly the problem, okay? And one of the technology that came for communicating between different systems in olden days is called CORBA. Common Object Request Broker Architecture. Okay, have you heard about COM? Microsoft COM controls. Whenever you are doing, let's say in a Microsoft document, you want to integrate another component into it. OLE, Object Linking and Embedding, or COM.
Common object model.
Right, Common Object Model. That's Microsoft's proprietary facility by which you can embed different things. For example, in a PowerPoint, you will embed a media now, right? These are all different systems interacting with each other. In Java world, the same technology was called as CORBA. And Ken Arnold is the designer of CORBA, and what he told is, you have to design distributed systems thinking that it will fail one day. Because absolutely designing a system without failure is very, very, very difficult. And that's what happening, right? Now, another issue. Take that example of integer, add integer a, comma, integer b, and I am writing a return a plus b. I want to add 10 and 12. What will happen? Add, I will call in my program 10, comma 12. Please understand. Huh? This is happening when? When I write the program and I execute the program, correct? I will have a main and I will execute this program. At the time it will call the function. 10 will be passed here. 12 will be passed here. I will be getting 10 plus 12, 22. That's how any programming language works. Assume that you are writing a function to add 1 million numbers. So you will write a function, 1 million numbers, okay? How will you read that particular numbers, 1 million numbers, at the time of executing the program, correct? Are you getting the idea? So when I run the program, it is going to read that 1 million numbers. Imagine the time. Even if you are storing that, you will read that numbers at the time of computation. Are you getting it? So, at compute time, second point is the most important point. At compute time, data is copied to the compute nodes. Are you understanding clearly that concept? Data is a big bottleneck. So assume that this 1 million is stored in a NAS or SAN or NFS. You are all familiar with all these things. What is NFS?
Network devices.
So you have stored it. And now you are writing the program. And you are going to read it. And this is coming through a pipe. What is that pipe? That thin yellow wire that you have behind your computer. Your Ethernet cable. What is the speed? 10 megabits per second. Assume that this data is 1 gigabyte. Tell me, simple mathematical calculation. 1 gigabyte is my data. 1 megabit per second, 10 megabytes per second is the network speed. How much time it will take for reading 1 gigabyte? 1 gigabyte is how many megabytes? One gigabyte is how many megabytes? Oh, yes, sorry.
2,000.
10 to the power of 3, correct? Almost 1000 megabytes divided by 10 megabyte per second. That means 100 seconds, correct? 1 gigabyte, 100 seconds. In one of my example that I am doing now is, this is about, what did you sell? How much data you are sending every day?
What's weekly?
50 gig, correct?
Yeah, the one.
So 15 to 100, 5,000 seconds. How many hours?
It takes
5,000
about an
seconds.
hour and a half.
Hour and a half.
Well, the SQL loader, the transmission, I think, is faster.
Of course, but it is coming through the network. It depends upon the network that you have, right? This is assuming this particular one, right? And assuming 50 gig. 50 gig and all is 40-year-old, 50-year-old back, you will tell about 50 gig and all. Today, Facebook is dealing with 1 petabyte of data, 15 petabyte of data, 12 petabytes of data. Amazon transactions itself is about 4-5 petabytes of data. And now you calculate it, 2 days. So for adding 2 numbers in that particular example, if that data is coming from such an input, 2 days I will get the result. So the business is getting impacted. It's not possible. So all this what I told you, right? And this speed I have told you. So where is exactly the biggest problem you think so far? The biggest problem so far is what? Network. Remember, in your big data course, in all your future, what big data addresses is network bandwidth and latency. In a nutshell, if you think deep, yes, it solves so many other problems. The most important is the network bandwidth and latency, because that is something which you cannot avoid, and big data solved it. How did they solve? They published 2 papers. We'll come to that, right? So we want to avoid partial failures. We want to recover the data. Whenever a component is failed, we want to make sure that the component is coming up. We want to make sure that the job is not affected. And we want to ensure that if more and more horses are coming in, we are able to scale. All these are the problems that we want to address. Now, we say we want to address, but this is not we actually. And in your WhatsApp group, you have the picture already. The man who was working on this was Dave Cutting. Dave Cutting was generating or working on a project called Nudge. Very simple. Create something like Google. That's what he was working on. Want to compete with Google. Started working a lot. He used an engine called Lucene inside, and he started working, but it is not scaling. He's not getting the expected result. Yahoo hired him. Dave Cutting, Arun Murthy, all these people Yahoo hired and told that, oh, modify it. Please make sure. At the time, as a bliss, Google published the paper on Google file system. Why Google file system? The problem, first problem is, I have a Mac, he has another Mac, he has Windows, another person has got Linux. If different people are having different file systems, our horse race example which I told you, that everybody should be identical, will not work. So let us create a layer, common layer. That common layer Google called Google file system. This fellow, taking his boys or kids elephant name Hadoop, created an equivalent file system which is called HDFS. So HDFS is a common layer irrespective of what operating system you use. Then you want to process something or compute something on this. You want to read the data. Just like adding 2 numbers or adding 1 million numbers. Assume that all the 1 million numbers are stored in HDFS now. You want to compute it. So he created a computation framework on the top of HDFS that's called MapReduce. That computation framework and the file system together is called Hadoop. So if somebody is asking you, define Hadoop. Hadoop is basically a file system called HDFS and a programming model called MapReduce built on the top of HDFS. Now what's the difference? Look at the example. Add in bracket integer a comma integer b, and then you write your code. And I told you that when I call add 10 comma 20, I am reading this data from the file storage at compute time. Remember I told you that second point is the most important point a couple of slides back, right? So at compute time, the data is traveling through the network. And just now I also told you that network and bandwidth is the biggest problem. To avoid that, assume that this add instead of the data is moving here. Entirely the programming model changed. Correct? Hey, come Ruji. So whenever you are doing, I just started at 8. Okay. Whenever you are executing this particular code at the time, the data is moving to the computation. So this is a file system and you moved it. Earlier what did you do? You read from here to your computer or computation. So moving computation to data. And what is that computation framework called? MapReduce. So HDFS is a file system. MapReduce is a programming model built on the top of that HDFS file system. Both together is called Hadoop. So if somebody is asking you what is Hadoop, what's the answer? It is a file system, a proprietary file system called HDFS, and a programming model built on the top of that file system, and that programming model is called MapReduce. MapReduce plus HDFS together is Hadoop. Clear? Okay. So the core concept is distribute the data as it is initially stored in the system. So here I told you that the data is moving, right? Who put the data here? In the HDFS. So you distributed the data already. So tell me, okay, forget about all these things. Now from whatever you understood, you are attending an interview and they are asking that, what is the difference between analyzing Twitter traditionally versus analyzing Twitter in a Hadoop environment? What's your answer now? I want to analyze the Twitter. I want to find out how many tweets Ruji tweeted today. Out of all the tweets, what is the difference between traditional system and a Hadoop-based system? What's your answer? In a traditional system, what did you do?
It's like define, it's a time consuming process in the traditional system, and also you have to define as a format.
Forget about format, logic and all. What is the core concept what you did in your traditional system?
Network.
In traditional system, you wrote a program and that program pulled the data from the Twitter. It pulled through the network. You executed it. You got the result of what all you guys tweeted about Hadoop today after 10 hours. Getting that's the thing. What will happen in the Hadoop world? Tell me. What is the difference? Not much, but what is the difference?
It's distributed.
All the Twitter data is distributed into your HDFS at night as a batch. It might have taken 10 hours. It might have taken the network, but you already did it. That's the key there. Don't ask me a question telling that, hello, this is 10 hours. The problem here is, this is happening at compute time. 9 o'clock you came to the office and you are executing it. So it is going to take 9 plus 6 hours. Getting it? 9 o'clock you came to office. Night I already distributed the data. And now I am going to run my tweet analysis on this data. I am going to get the result in 9:10 a.m. Now tell me, that's the difference. Don't tell me that you are not pulling the data. We are pulling the data. Key is We distributed the data all together, already ready for computation. Okay, in this model, CEO is now asking, how many people have tweeted? How many trending topics are there today? What are the top trending topics? Again, you are going to write another program by another team at 10 o'clock. Again, it is going to take another 6 hours. Again, it is going to pull the data. Data is already distributed. 10 o'clock CEO is asking another MapReduce program on this particular data. 10:05, he is getting the answer. That's what Hadoop is bringing. If you think everything is pulling the data, everything is this one, you will never learn Hadoop. You should get that thinking different. Hadoop is for batch-based processing. Hadoop is not for real. If I am asking you one question, that now who tweeted fast? That's a different question. It is not a Hadoop question. Hadoop should not be used for that. That's the reason why anywhere I go, when I architect, I won't tell replace your RDBMS, take out and put it into Hadoop. And that's what everybody does. Creating a data lake by removing the RDBMS. Never ever you can do that. Your relational database management
in
system.
addition to what the data you already have.
Yeah, you can't. That is a transactional system. EF code rules, 12 code rules, atomicity, consistency, isolation, durability, acid properties, everything is followed by your RDBMS, Oracle, MySQL, SQL Server, everything. You can't change that one. Why? Because if you want a quicker answer, there is nobody who can beat an RDBMS. Try with Oracle. Can't. That's the best database in the world. Teradata, good data warehouse. What's different is batch-based processing. Analyze in last month how many people in the world talked good about Google. Analyze at a particular time how many people are searching for a particular thing. Analyze out of all the people came to this particular shop, how many gave me good feedback. Hadoop comes in. So always remember, adding two numbers is not a Hadoop problem. Hadoop is meant for batch-based analytics, batch-based programming. What is Hadoop? File system plus computation on the top of it. And what is that computation called? MapReduce. Right? So, distribute the data, right? And applications are written in high-level code, nodes talk to each other as little as possible. All these things you will learn, but now just listen what is happening. Okay. What is the question I asked? How many tweets Ruchi tweeted, right? That's a question that I asked you. And the data is already distributed, correct? Can you guess now how the MapReduce or computation will work? The computation will go here and we will find out in this how many Ruchi's tweets are there. In this, how many tweets are there. In this, how many tweets are there. So, it is happening independently. And this is not talking with this. And remember, these are two different computers. And what did we tell just now? Network is the biggest problem. So, you avoided talking between each other. Network is zero. Look at the approach. It's an amazing innovation. So, everybody will work independently. Think like, I want to create food for 500 people. In traditional programming, in my house, in my gas stove, I created all that food for 500 people. In Hadoop-based programming, assume that in your community, there are 20 houses. All the 20 houses are independently preparing the food at the same time, and then you are combining everything together. And when each person is making in their house, they are not talking each other, no network. And that's what Hadoop is bringing in, okay? So data is spread in machines in advance and computation happens where the data is stored. you should ever make a mistake when somebody is asking you what is the definition of MapReduce. What is MapReduce? MapReduce is a distributed computation. The difference is computation goes to the data. In the older programming, data came to computation. Think about this diagram. Data came to the computation. Computation went to the data. Opposite. Completely opposite. And see that approach. And now the most important thing. What are these machines called? They are nodes in a Hadoop system. Normally it will look like this. Have you ever seen a data center? This will be a big rack. And inside the rack, these are all called blades. And this will be one node, 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 like that. HP's latest invention is they have created something called a moonlight servers. These are called moonlight servers. Just go to Google and then that's how it will look like. It's a small diagram. Let me show you a real data center. See, this is exactly the way in which a data center will look like. Here's the diagram. Can you see that? Racks. This is how your data center is. Everybody's data center. Should get a chance, you should go. I was there in HP's data center for about 20-25 days. A real, beautiful data center. One is in Boston, one is in Bangalore. And they will plug in, and those are all your nodes. We draw like this, but remember that each of these are computers. So 1, 2, 3, 4, 5, 10 will be there, 10 will be there, 10 will be there. So this rack itself is about 1,000 nodes. That's how a data center will look like. And that's how the Hadoop cluster is created, right? And yeah.
The cores are the
Inside, that is in the CPU.
the boards.
Yes, that's in the box, right? That's in the motherboard, the CPU, where the CPU is there. Core is part of CPU. And what is the latest? CPU also is failing now. Machine learning. Very advanced artificial intelligence. I want to take all your images and predict who is my kid, who is your kid, etc., from the pictures. That requires lots and lots of power. GPU, graphic processing unit. One of my friend in another batch, I don't tell you the name. I told him to buy a computer, so he went and Best Buy told that we have got a GPU. Hey, GPU is for graphics, it's very less powerful, I don't want it. He told that. But the story is opposite, right? If it is GPU, immediately you should buy it. GPU is the most powerful. Now Dell is coming up with
That's
GPU
for like
machines.
crypto mining.
Correct.
They use.
Mining, cryptography,
GPU.
blockchain, everything.
Yeah.
Okay? That's called a GPU. GPU also failed. Imagine Google Lens. Millions, trillions of images and then want to tag it and then want to analyze it. Facebook. What is it? The next one. TPU. Tensor Processing Unit. You will see another 2 years you will be sitting with a laptop of GPU. So processing power is increasing and the data is decreasing. So what is Hadoop? It's a file system. Okay, so in the last class what I did is I just made everybody to use Hadoop. So let's assume that I have got some data. Always the classic example I take is twinkle twinkle little star is my data. How I wonder what you are is another data. Okay? There are some assumptions I want you to make. Assume that the total size of this particular data is 256 MB. And you learned today that in Hadoop, when you distribute the data is distributed as blocks and the block size is 128 MB. This you by heart. It was 64 MB earlier versions of Hadoop. They increased this 128 MB. Can you tell me an advantage? What is the block size of Windows? Very small. Exactly, I don't know why, because different versions have done. Very small, not in MBs, KBs. What is the problem if the block size is very small? If 1 GB of data is there, that 1 GB will be divided to block.
You have a
lot of blocks. So when you process it, operating system has to assemble all these blocks, right?
Is MapReduce what maps the data to the...
Yeah. What they did? Very big. So, because we are dealing with big data, if you use that Windows approach, big data will be dead. Processing will be dead. 128 MB is the default size. So, our data is 256 MB. So, let's assume that this line is 128 MB, this line is 128 MB. I want you to find out how many twinkles are there in this. That's the problem. What did we learn just now? Data is distributed to the nodes before computation. And assume that I have got 5 nodes. Seiko, Ruchi, Srinivas, Surya and Bhaskar. 5 nodes I have. So what I need to do? I need to distribute the data. So let's start distributing. So I'm going to give you, this is your HDFS file system. So Seiko is getting 1. And what are you, Seiko, going to do? You are going to take this data and you are going to write it in a block.
Twinkle.
Yeah, please, no, the entire line. That is 128 MB. So please do write twinkle, twinkle, little star there. And what I am doing, okay, I am doing a very important role here and I am going to paste what I am doing here, okay. That I am going to tell that Seiko, how do you spell?
SAICO.
SAICO, Seiko, block 1. This is what I did. Now I want to be little bit careful. Why? Because we told one of the problems in traditional computing is if the data is gone, everything is gone. Correct? So to make sure that I can retrieve the data whenever there is a data loss, I am going to create a copy of what Seiko has. And not one copy, I am going to create 2 extra copies. That means total 3 copies of the data will be there in the nodes. So 1 copy, I am very careful, I am going to give to Ruchi, and another copy, let's assume that I am going to give to Surya. So please write twinkle, twinkle, little star, which is Seiko's data. The same data, you are creating a copy. And what I am going to write here, copy is in B2 Surya and B3 is Ruchi. Sorry, B1. B1's copy is in Ruchi and Surya. See what I am doing, very, very important. Of course, you have the data. First of all, did I store any data? What did I store? What is it called? Metadata. Data about data is called metadata. All right. Now let us take the second line. Hey, Seiko's disk is full. So what I am going to do is, this time I am going to keep the primary copy in Bhaskar. And the copy of this, since his HDFS is very big, I am telling that, okay, Surya will keep a copy of How I Wonder What You Are, and Srinivas is empty, so Srinivas is going to create, and this time Ruchi is not getting the copy. So the copy is getting created. You should write How I Wonder What You Are. That is the second data. Okay, and what I am going to do? I am going to write the primary copy is in Bhaskar, which is B2, and the copy is there in B2 Surya, B2 in Srinivas. Please understand the things that happened. What is the size? 128 MB. Never ever forget. Hadoop block size is 100. Just to think this class today. Today's class. The Hadoop default block size is 128 MB. I told you no. These are two lines. I am assuming that this is 128 MB. This is 128 MB.
That's a big block size.
Yeah, it's a big block size.
But it's a default, so
Yes,
you
it is.
typically can change it.
Correct. Right? So 128 MB is the block size. Clear? Second, how many copies of each block will be created? 3 copies. In the 2 copies, but total 3 copies. 3 copies in the system. By default, replication factor in Hadoop is 3. And this, sorry?
It's RAID.
Yes, it's RAID. Very good. Yeah. You know about the hardware, that's why. All those are the RAID blocks. Redundant array of independent disks.
What if you decide you want to change the block size? You have to reinstall?
No, you have to do the configuration. I'll show you all those things.
Yeah, okay.
But that is dangerous because all programs and everything is built.
Once you're...
If you are storing Hadoop, just storing, no computation, then you may change it. My suggestion is not to touch the default value. So for example, somebody is using as an archival tool for Hadoop, no processing.
Right.
From Oracle, you want to store it. Okay, increase the block size and store it.
Yeah.
Increase the block size and store it. You can. But you know, the problem is that there are so many programs, later Spark and all those things, all are configured for the default settings. Right? So everything will synchronize if you use those default settings. But you can change it.
You can? Okay.
Yeah.
I thought you were
Of course. No, you can change it.
Without having to do like a backup and reinstall or something like that?
Not dynamically. Of course. Once the HDFS is there, you have to do the disk balancing. That is an admin part of it.
Oh, okay.
Yeah, you can do it. Valid question.
Oh, okay.
And also, this, some people will change it. They will make it as, I need only 2.
Oh, I see.
I need only 2. Some people will make it as 10. You can change that one also. Everything is configurable.
So it's more resilient.
Correct. So, default block size, default replication factor. Got all these 2 things, right? Now, the place where the data is stored, the HDFS nodes, they are called data nodes. So, Seiko, Ruchi, Srinivas, Surya and Bhaskar are the data nodes. I, who distributed the data and who is having the authority to distribute the data and who has the metadata of all the things that is in the HDFS system is called a name node. Name node, data node.
Name node is...
Core part of Hadoop system.
What is the name node again?
My role. What I did. What did I do?
You mean to assign the nodes? Or?
What did I do? This is what I did. Assigning the data and representing which block resides where. You do not know anything about the file system now as a Hadoop node. Who knows? Name node knows. Independently, you are just dumb now. What I mean by dumb is that you know I have got some data, that's all. Where is the rest of the data? What is the entire data looks like? Is it the 2 lines, twinkle, twinkle, little star, and how I wonder what you are is my entire file? You don't know. Who knows? This is called a register or FS image, file system image.
So it's like the master.
Exactly. It's very, very similar.
And where it is saved?
Very good. Okay. Name node is a separate node, a super powerful node in the Hadoop file system. This will be stored in the name node's file system but available to you in the memory. Why it is kept in the memory and file system? Can you guess? Memory means?
It's fast.
Fast. Very good. Yeah. Excellent. Because there is no need of reading from the file system. Why it is stored in the file system? If name node goes down.
So it's like a metadata.
Yes. Yes, exactly.
And what is the size?
Size?
Is its size also 128? I mean,
No. That is not a block. It is not a block. It is completely different from a block. Its size is not 128. Only block size is 128. This is just a normal file.
So it wouldn't be huge if it's in memory.
Yeah, it will. So name node will be huge memory, good network bandwidth. Why? Why good network bandwidth? Now can you guess? If I am writing the MapReduce program, that program will contact whom first to understand where is the data? That is why it is kept in the memory. So that everybody, go. Hey, where is the data? Where is the data? Where is the data? And suddenly, Seiko node goes down. And when the Seiko node goes down, immediately, hey, where is the copy? Ruchi is having the copy.
So
Will come
each
to you.
node has 3 copies
Yes.
by default.
But the copies are not stored on you. Copies are stored elsewhere. 3 copies, but not in the same
Right.
system. Hadoop is very, very careful about security and reliability. So, if somebody is asking you, hello, then Hadoop, all you are dividing it into blocks. Where is the security or reliability? What is the answer? Reliability in Hadoop is managed by the replication factor. If you want to be more reliable, you make it as 10.
So all 3 would have to go down.
Correct. And that never happens.
Right.
Ideally. Unless the entire
So if
data
you make
center.
it 10, you make it.
Yeah. Unless the data center itself is going up.
But wouldn't it be different data centers?
That there is a disadvantage. Very good question. There is a big disadvantage for Hadoop currently. Unless you buy external costly softwares, Hadoop does not replicate data across nodes in a different data center. That rack I showed you,
Oh,
it should be within that. Why? Why?
speed.
Network.
Yeah.
Hadoop is all about network solving. And if you are keeping the data, then what is the difference between reading the data from normal Twitter and reading from HDFS?
What would be the point then?
Yeah, there is no whole point. Right? So that's about HDFS. This is what I covered in the last
But
class.
here we have a thread, right? If something data center happens,
Ah.
then everything will use.
Yeah, that is why separate hardware will be there, separate software is there. Hadoop is another software. See the name. And there are some, okay, which will do the cross data center replication. Another one. Now what everybody does, when you are having your HDFS file system, if the security and your company is allowing, they will create a copy of that HDFS in Amazon. Easy to finish, right? That's what everybody is doing nowadays.
In the cloud, you mean?
Yeah, but according to the data privileges, data security and all. You know, there is a surprising thing here. My company does not allow the data to be gone into Amazon. No way. But my company will buy a software from Bhaskar. Bhaskar can store in Amazon. What is this? I don't know. Right? Oh, okay. So
It's a loophole.
yeah, that's where the world is going on. Why? Because I will indemnize him as per
If
the
anything
company
goes
security.
wrong,
If anything happens, right? If I do, I can't indemnize anybody. That might be the reason, right? That's where
It's all about cost.
cost. Next class, we will install the virtual machine and you will write the HDFS commands. What you did today in the paper, you will make the system to do it and we will create the name node. Okay? So this is what I covered in the last class. Maybe I have told a little bit more or a little bit less, but this is the crust of it. I sincerely wanted that Vara also to attend to it. He's gone. So we'll continue installation of Hadoop in the next class. You need to bring the laptop, 16 GB. RAM is the minimum, which you were not there, so 16 GB.
I have 16.
Very good, excellent.
16, I thought you said 8.
8 is okay, provided your Mac and everything
I
is
got
there.
it 16.
Anyway, good, okay. 16 will fly.
Even
8.
though Apple says this only takes 8.
Okay.
But I found out,
Oh,
and I said, on the internet said, yeah, it'll take 16, even though Apple says it.
wow. That is very good. So you will see the difference. The difference
Oh,
is
yeah.
8 GB. 8 GB
I
it
had
will work.
4.
8 GB it will work, but if it is 16 GB, you'll see when
Yeah.
you click, it will be
Yeah.
faster. Otherwise, we'll be spending time
Right,
starting and you're doing things. Okay, so What I'm going to do after I go home, I will send you this particular